Good morning, students. In the previous class, we are completing about significant figures, rules for calculating significant figures, and rounding of numbers. Rounding of numbers. In this session, we are discussing arithmetic operations using significant figures, similar to that of scientific notation. That is, addition of significant figures, subtraction of significant figures, multiplication of significant figures, and division of significant figures. Very important topic, student. In competitive point of view as well as in board point of view, compulsory one question from the arithmetic operations of the significant figures. Carefully you will concentrate. It will be very important, student. First one, addition and subtraction of significant figures. Addition and subtraction of significant figures. In addition and subtraction, the final answer should be reported to the same number of decimal places as the number with minimum number of decimal places. In addition and subtraction, the final answer should be reported to the same number of decimal places as the number with minimum number of decimal places. Minimum number of decimal place, student. For example, 67.32 plus 10.3. 67.32 plus 10.3. This first number is having two decimal places. That is, after decimal, two places are present. Hence, the first number is having two decimal places. Whereas, second number, after decimal, one digit is present. Hence, it is having one decimal place. Decimal place means the number of digits after the decimal point are known as decimal place. Therefore, 67.32 has two decimal places. 10.3 has one decimal place. If you add the two numbers, you will get 77.62. 77.62. But this answer is not correct, student. This answer is not correct. Why? Because the reason is, according to the rules and regulations of the significant figures and decimal places, the final answer must be reported to the same number of decimal places as the number with the minimum number of decimal places. The first number is having two decimal places, second number is having only one decimal places. Hence, the final answer round off to one decimal places. Rounding off to one decimal places. Here we are applying the round offing rule, students. Yesterday we are discussing, if the last digit should be dropped. Why? Because we can round off this number to only one decimal places. Therefore, you have to drop the last digit. If the last digit to be dropped is less than 5, such that the previous number will be, the preceding number will be retained. The preceding number does not undergo any change. Clear, students? The 77.62 has two decimal places, but the decimal places are rounded off to only one decimal places. Hence, the last digit 2 has to be dropped. If the last digit to be dropped is less than 5, such that the previous number, the preceding number 6, that is retained, it does not undergo any change. Hence, 77.6 is the rounding of 77.6. Why? Because, student, the 10.3 has one decimal places. 67.32 has two decimal places. The final answer must be reported to the same number of decimal places as the number with minimum number of decimal places. Minimum number is 10.3 because that is having only one decimal places. Therefore, student, 77.6 is the correct answer. In objective questions, they will give questions like this, student. What is the final answer of the following addition? 67.32 plus 10.3. First option, they are indicating 77.62. They are direct, everyone right, this is the correct answer. But the correct answer is 77.6 is the correct answer. 77.6 is the correct answer. In additions, they are given like this. You will check which is the minimum number of decimal place. Then the final answer is reported to that minimum number of decimal place only. Clear, students? Right. Next, one example for subtraction we are discussing today. That is 6.56 minus 0.031. 6.56 minus 0.03. 6.56 has two decimal places because of the decimal two digits are present. 0.031 has three decimal places because of the decimal three digits are present. Hence, the final answer must be reported to two decimal places only. Two decimal places only. But the actual answer will be 6.529. 6.529. It is having three decimal places. It is having three decimal places. Hence, the 6.529 is rounding off to 6.53. 6.53. Hence, it is having two decimal places. It is having two decimal places. How can round off, student? Yesterday we are discussing if the 6.529 is having three decimal places. The three decimal places can be changed to two decimal places by dropping the last digit. If the last digit to be dropped is more than 5, such that the previous number is increased by 1. Hence, increased by 1 is already 2 is there, plus 1. Hence, it is 3. Hence, 6.53 is the correct answer. 6.53 is the final answer. Why? Because the reason is the final answer must be reported to the same number of decimal places as the number with the minimum number of decimal places. Here 6.56 has minimum number of decimal places, that is 2 decimal places. But the final answer is having only 3 decimal places, that is round off to 3 decimal places, 6.53. How it is round off, student? The last digit to be dropped is more than 5, such that the previous number is increased by 1, hence 6.53. Hence 6.53 is the correct answer. Therefore, that is the final answer of the subtraction. Next, students, next arithmetic operation, that is multiplication and division of significant figures. Multiplication and division of significant figures. In the multiplication and division of significant figures, the final answer should be reported to the same number of significant figures as the number with minimum number of significant figures. In the multiplication and division, student, the final answer must be reported to the same number of significant figures as the number with minimum number of significant figures. Minimum number of significant figures, student. For example, 6.26 into 5.8. 6.26 into 5.8 multiplication. First number is having three significant figures because all the non-zero digits are significant. Second number is having two significant figures because same principle, all the non-zero digits are significant. The multiplication of these two numbers is 36.308. 36.308. Here, how many significant figures, student? Totally 5 significant figures are present. 36.308 is having 5 assets because the reason is all the non-zero digits are significant and the zeros present between two non-zero digits are significant. Here 0 is also significant. Totally 5 significant figures are present. Totally 5 significant figures are present. But the final answer is reported to how many significant figures, student? Only 2 significant figures. Only 2 significant figures because minimum number of significant figures only the final answer will be reported. Therefore, the 36.308 is a round off. The round off means at a time is not possible. First, the last digit 8 can be dropped. How can drop means how can drop, student? If the last digit to be dropped is more than 5, such that the preceding number increased by 1 unit, already 0 plus 1, then it will get 1. That is 36.31. 36.31. Next one. Here 4 significant figures are present, but we can require is 2 significant figures. Again, if the last digit to be dropped, one is less than 5, one is less than 5, such that the preceding number will be as is. The preceding number will be retained, it does not undergo any change. Hence 36.3. 36.3. Next, students, again 36.3 is having 3 significant figures. But the final answer is reported to only 2 significant figures. Therefore, students, the last digit 0.3 is dropped since it is less than 5, such that the preceding number does not undergo any change. Hence 36, 2 non-zero digits, all the non-zero digits are significant figures. Hence it is having 2 assets, 2 significant figures. Therefore, student, the multiplication 6.26 into 5.8, the correct answer is 36, but not 36.308 because according to principle and concept the final answer should be reported to the same number of significant figures as the number with the minimum number of significant figures in multiplication student, in multiplication. Next one student, division. 5.27 divided by 12 5.27 is having 3 significant figures, 12 is having 2 significant figures, hence the final answer must be reported to 2 significant figures because these are minimum number of significant figures. Therefore 5.27 divided by 12, 5.27 divided by 12, that equal how much student? Nearly 0.439. How many significant figures student? Always the point 0, the 0 present before point is not significant, just it is the 0 to indicate the decimal point. Whereas 439, all the non-zero digits are significant. Here 3 significant figures are present, but the final answer is reported to less number of significant figures, minimum number of significant figures. Hence the last digit to be dropped. Hence the 9 is greater than 5 such that the preceding number is increased by 1 unit, Hence 0.439 can be reported as 0.44. Therefore this 0.44 is having 2 significant figures. Why? Because the 0 present before the decimal point is not significant. 4,4 are the 2 non-zero digits, hence they are significant. Therefore the minimum number of significant figures are 2. Here the final answer also reported to 2 significant figures, 0.44. Hence that is the correct answer. Clear students? It is the division of the significant figures. Remember student, addition and subtraction, we are considering the number with the minimum number of decimal places, whereas in the multiplication and division we are considering significant figures. The number with the minimum number of significant figures will be considered while reporting the final answer. Here variation student, addition and subtraction, decimal places we are considered. In multiplication and division we are considering number of significant figures. Okay students, copy this. Okay students, that significant figures topic is completed. Next last subtopic in this third topic of some basis of chemistry, that is dimensional analysis or unit factor method. This method can be used to convert units from one form to another form. The analysis that can be used to convert the units of the system from one form to another form, that is kilometers to meters, meters to centimeters, centimeters to millimeters, kilograms to grams, grams to milligrams, milligrams to nanograms, liters to meter cube, liters to milliliters, liters to centimeter cube. That is one form to another form. The analysis that can be used to convert from one form to another form are known as dimensional analysis. This analysis can be used in numerical student. While solving the problems, it will be very much useful. We are discussing some examples student. First one, to convert units from one form to another form, we are using dimensional analysis. It can be also known as unit factor method. For example, 2.56 meters into centimeter cube. We know that 1 meter is equal to 100 centimeters. Remember student, they are asking meters to centimeters. Therefore, you can identify the relation between meters and centimeters first. That is the first precaution student. They are asking convert 2.56 centimeters into 2.56 meters into centimeters. Then you can identify the relation between meters and centimeter. We know that in SI system prefixes we are discussing meter and centimeters and millimeter. We know that 1 meter is equal to 100 centimeter. Therefore, both are equal. 1 meter is exactly equal to 100 centimeter. Therefore, 1 meter by 100 centimeter is equal to 1, as well as 100 centimeter by 1 meter is equal to 1. Hence, both are equal to 1, both are equal to 1, hence this factor is called unit conversion factor, unit conversion factor. This factor can be used to convert the system, the number from one unit to another unit, one unit to another unit. Because of this reason only it is called unit conversion factor. Conversion means from one form to other form. Units means the units can be changes to meters to centimeters, meters to centimeter, and it is known as unit conversion factor, unit conversion factor. Because of this reason only the dimension analysis are also known as unit factor method, unit factor method. Okay students, right. Now enter into problem. 2.56 meters, 2.56 meter. This 2.56 meter can be written as 2.56 into 1, 2.56 into 1. There is no change. Why? Because we can multiply with any number with 1. There is no change in that value. Hence 2.56 meters into 1 is nothing but unit conversion factor. In the place of 1, I am writing 100 centimeter by 1 centimeter. 100 centimeter by 1 centimeter. Why? Because we are converting 2.56 meters into centimeter means the centimeter is always in numerator, always in numerator. Hence 1 is nothing but 100 centimeters by 1 meter. Therefore meter get cancel each other, meter get cancel each other. 2.56 into 100 centimeter, 2.56 into 100 centimeter, that is nothing but 2056, 25600 centimeters, 25600 centimeters, that is 25,600 centimeters, 25,600 centimeters. Here you can take two precautions student. One is unit conversion factor you have to identify, that is meters into centimeters. Another one is here which unit factor you have to consider, either 100 centimeter by 1 meter or 1 meter by 100 centimeter. Here you can consider 100 centimeter by 1 meter, because meter get cancel each other, you will get centimeter, because you have converted into centimeter, you have converted into centimeter. Therefore to convert meters into centimeters, the unit factor will be 100 centimeter by 1 meter, 100 centimeter by 1 meter. Therefore, for your much more clarity, I will give a reverse example student. How can you convert 25,600 centimeter into meters? This 25,600 centimeter can be written as 25,600 centimeter into 1. Any problem student? Why? Because same value will be obtained. But this one can be written as, like this student, 1 meter by 100 centimeter, 1 meter by 100 centimeter. Because you have to convert centimeters into meters means meter always in the numerator, meters always in the numerator. Therefore centimeters get cancel each other and zeros get cancel each other. 256 into 1 meter, that is equal to 256 meters. 256 meter will be obtained. Yes students, therefore while doing conversions from meters to centimeter, we are using unit factor, that is 1 meter by 100 centimeter is equal to 1, 100 centimeter by 1 meter is equal to 1. But while converting meters into centimeters, we are using 100 centimeter by 1 meter. While converting centimeters to meter, we are using 1 meter by 100 centimeter. Here you can take more precautions student. And second one is 1 meter is equal to how many centimeters? 100 centimeter for this problem. Clear students? Right. Next one, second example student. Convert 2 liters into meter cube. 2 liters into meter cube. We know that 1 liter is equal to 1000 ml, 1000 cc cube. That is 1 liter is equal to 1000 ml, that equal to 1000 centimeter cube student. Why? Because 1 ml is equal to 1 centimeter cube. 1 ml is equal to 1 centimeter cube. Therefore 1 liter is equal to 10 cube. 1 liter is equal to 10 cube. That centimeter cube means here student 10 to the power of minus 2 meter. 1 centimeter is equal to 10 to the power of minus 2 meters. Why? Because student, the reason is 1 meter is equal to 100 centimeters. 1 meter is equal to 100 centimeter. Then 1 centimeter is how much, student? 10 to the power of minus 2 meter. That is 0.01 meters. 0.01 meter. This point I will let you, student. 1 meter is equal to 100 centimeter. Then 1 centimeter is equal to how many meters? Means 0.01 meters. That is nothing but 10 to the power of minus 2 meter. Therefore, 1 centimeter is equal to 10 to the power of minus 2 meter. In the place of centimeter cube, I am substituting 10 to the power of minus 2 whole cube. 10 to the power of minus 2 whole cube. Therefore, 10 cube, this 10 to the power of minus 10 to the power of minus 2 meter whole cube can be written as 10 to the power of minus 6 meter cube. Why? Because 10 to the power of minus 2 whole cube nothing but 10 to the power of minus 6, and meter whole cube nothing but meter cube. Meter whole cube nothing but meter cube. Therefore, 10 cube into 10 to the power of minus 6 meter cube. 10 to the power of minus 6 meter cube. 10 to the power of minus 6 meter cube. We know that it is in the form of 10 to the power of x into 10 to the power of y. Therefore, 10 to the power of x minus y is the correct one. 10 to the power of 3 plus 10 to the power of minus 6. Therefore, 10 to the power of minus 3 meter cube. 10 to the power of minus 3 meter cube. If bases are equal, powers are added. 3 minus 6, that is nothing but minus 3. Therefore, conclusion: 1 liter is equal to 10 to the power of minus 3 meter cube. Our relation will be obtained. What is the relation, student? The relation between liters and meter cube is 1 liter is equal to 10 to the power of minus 3 meter cube. 10 to the power of minus 3 meter cube. By using this relation, we are converting liters into meter cube. I will explain once again, student. 1 liter is equal to 1000 ml. But 1 ml is equal to 1 centimeter cube. 1000 ml is equal to 1000 centimeter cube. Therefore, 1000 can be written as 10 cube. Next one, centimeter. 1 centimeter is equal to 0.01 meter, because 1 meter is equal to 100 centimeter. 1 centimeter is equal to 0.01 meter. That is nothing but 10 to the power of minus 2 meter. 10 to the power of minus 2 meter. 1 centimeter is equal to 10 to the power of minus 2 meter. 1 centimeter cube is equal to 10 to the power of minus 2 meter whole cube. 10 to the power of minus 2 meter whole cube. Since 1 centimeter is equal to 10 to the power of minus 2 meter. Therefore, 1 liter is equal to 10 cube into 10 to the power of minus 6 meter cube. 10 to the power of minus 6 meter cube. 1 liter is equal to 10 to the power of 3 into 10 to the power of minus 6 meter cube. That is 10 to the power of minus 3 meter cube. Therefore, our required relation is 1 liter is equal to 10 to the power of minus 3 meter cube. 10 to the power of minus 3 meter cube. Therefore, from this one, 1 liter by 10 to the power of minus 3 meter cube is equal to 10 to the power of minus 3 meter cube by 1 liter is equal to 1. That is unit conversion factor. 1 liter by 10 to the power of minus 3 meter cube. 10 to the power of minus 3 meter cube, student. Okay, students, right. Now we have to convert liters into meter cube. Meter cube is the conversion factor. That meter cube is in the numerator. Like similar to meters and centimeter. Therefore, 2 liters can be written as 2 liters into 1. Therefore, 2 liters into 10 to the power of minus 3 meter cube by 1. This 1 is the unit conversion factor that can be written as 10 to the power of minus 3 meter cube by 1 liter. Liter get cancel each other. 2 into 10 to the power of minus 3 meter cube. 2 into 10 to the power of minus 3 meter cube. Therefore, 2 liters in the form of meter cube is 2 into 10 to the power of minus 3 meter cube. 2 into 10 to the power of minus 3 meter cube. Okay, students, like this, so many examples are there. From one system to another system, we are using the dimensional analysis or unit factor method. Okay, students, right. Basing on this topics, 3 topics, that is importance of chemistry and measurement of units and properties of measurements. Last one is significant figures. 3 topics are completed, student, in some basics of chemistry. Basing on these 3 topics, we are solving the objective questions. Tomorrow, we are today we are sending some questions basing on these 3 topics in some basics of chemistry. Today and tomorrow we are discussing the objective questions basing on the 3 topics. In that classwork is there, homework is there, all questions are there. What are the classwork questions are there, I will solve. In homework questions also, difficult examples also I will solve. Remaining homework questions we will solve, student. Today already we are sending the questions. Today evening or tomorrow you will get students. You can solve that questions. Okay students, right. Now you can download the paper and observe the questions, objective questions regarding the JEE and NEET examination, students. Okay students, now we are discussing the objective questions based on the first three topics of some basics of chemistry. Okay students, right. The first question is the correct relationship between picometers and nanometers. The correct relationship between picometers and nanometers. That is students, the picometers, that is 1 nanometer is equal to how many picometers? Here some options are given students. That is 1 nanometer is equal to 1000 picometers, 1 nanometer is equal to 10 picometers, 1 picometer is equal to 10 nanometers, 1 picometer is equal to 100 nanometers, 100 nanometers. They are clearly asking student what is the relation between picometers and nanometers. Picometers and nanometers. First one student, 1 nanometer is equal to 10 to the power of minus 9 meters. In the prefixes we are discussing centi, milli, micro, nano, pico, femto, hepto, hecto, jecto. That 20 relations are there students. You can by heart in competitive examinations. Okay student, right. 1 nanometer. Nano means 9 student. N stands for 9. Nanometer means 10 to the power of minus 9 meters. 10 to the power of minus 9 meters. 1 picometer is equal to 10 to the power of minus 12 meters. 1 pico means 10 to the power of minus 12. Pico means 10 to the power of minus 12 meter. Therefore, 1 nanometer by 1 picometer. How much students? Nanometer means 10 to the power of minus 9 meter. Picometer means 10 to the power of minus 12 meter. Meter get cancel each other. Therefore, 10 to the power of minus 9 into 10 to the power of 12. Why? Because this 10 to the power of minus 12 in denominator that enter into numerator, then minus can be changes to plus 12. Minus 12 can be changes to plus 12 students. Therefore, 10 to the power of minus 9 into 10 to the power of 12. We know that the bases are same, then powers are added. 10 to the power of minus 9 plus 12, that is nothing but 10 cube. Therefore, 1 nanometer by 1 picometer is equal to 10 cube student. Hence, it implies 1 nanometer is equal to 10 cube picometer. That is 1000 picometer. That is 1000 picometer. The relation between nanometers and picometers is 1 nanometer is equal to 1000 picometers. 1 nanometer is equal to 1000 picometer students. Is it clear students? Once again, 1 nanometer is equal to 10 to the power of minus 9 meter, 1 picometer equal to 10 to the power of minus 12 meter, 1 nanometer by 1 picometer is equal to 10 cube. Therefore, 1 nanometer by 1 picometer equal to 10 cube. It implies 1 nanometer is equal to 10 cube picometers. That is 1000 picometers. That is 1000 picometers. Okay students, next objective question, that is conversion student. Convert the 200 degree Fahrenheit into centigrade. 200 degree Fahrenheit into centigrade student. We know that the Celsius scale temperature can be converted into Fahrenheit scale as well as Kelvin scale. The relation between the Fahrenheit scale and Celsius scale is given by degree Fahrenheit is equal to 9 by 5 into degree centigrade plus 32. 9 by 5 into degree centigrade plus 32. To convert Fahrenheit scale into Celsius scale, we are not using this formula. Why? Because if Celsius scale temperature is given, we can convert it into Fahrenheit scale by using this formula. But here what they are given, Fahrenheit scale of temperature is given, we can convert it into Celsius scale student. Therefore, Fahrenheit, the relation can be obtained by using the small calculation. That is Fahrenheit temperature minus 32 plus 32 is right side, and the left side it can becomes minus 32. That is equal to 9 by 5 into degree centigrade. 9 by 5 into degree centigrade. It implies Fahrenheit temperature minus 32 into 5 is equal to 9 into Celsius temperature. 9 into Celsius temperature. That implies degrees. Therefore, degree centigrade temperature is equal to Fahrenheit temperature minus 32 into 5 by 9 into 5 by 9. It is the relation to determine the Celsius temperature if Fahrenheit temperature is given. Therefore, substitute student, except Fahrenheit temperature, all are constant. That is 200 minus 32 by 9 into 5. That is 200 minus 32 is equal to 168 into 5 by 9, that is nothing but 840 by 9, that is nothing but 93.3 degrees centigrade. 93.3 degrees centigrade. The temperature in Fahrenheit scale temperature, if it is 200 degree Fahrenheit, then the same temperature in the Celsius scale is 93.3 degrees centigrade. 93.3 degree centigrade. Here you have to remember crucial formula, student, which formula we are using to convert Fahrenheit scale of temperature to Celsius scale. That is, Celsius temperature degree centigrade is equal to Fahrenheit temperature degree Fahrenheit minus 32 into 5 by 9 into 5 by 9. If Celsius temperature is given, that is Fahrenheit temperature is equal to 9 by 5 into degree centigrade plus 32. Degree centigrade plus 32. Copy these two questions, students.